Hi friends, welcome back. Grab your notebook. It's time to talk triangle similarity for side, side, side. So if we have two triangles and their sides are proportional, all three sides are proportionate to the all three sides of another triangle, then those triangles are similar. So grab your notebook, make sure you write down your definition so you have it. If the measures of the corresponding sides of two triangles are proportional, then those triangles are similar. So that's a formal way of saying what I was explaining. Okay, so let's take a look at how that works. For example, number one, are these similar? If so, write a similarity statement. So let's take a look at these guys. All right, we have these two triangles. Now, I think the easiest way to do this is if you are going to be determining side, 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 what we need to do is look at these guys and say, okay, we have a small, a medium, and a large. Now, I'm using the dashes that usually we reserve for congruent, and that doesn't mean that these are congruent, but I'm just using it as a notation to myself to make sure that I'm comparing similar, the correct corresponding parts. So you'll see I took my smallest, my medium, and then my largest. I'm going to do the same over here. The smallest, the medium-sized one, and then the largest, and that helps me organize this. So when I compare these guys, I'm going to say 24 over 52. Is that equal to my 42 over 91 and 54 over 117? Now, what I could do is reduce down all of these fractions until I get to something. So if I reduce these guys, let's do that. We're going to cut these guys in half. And if I do that, I get 12 and 26. Now, if I cut those ones in half again, I get 6 and 13. All right. Can't go any further because 13 is prime, so we'll leave it at that. If I divide this guy by 7, I will get 6. Divide this by 7, I get 13. Okay, so right now I have 6 over 13 equals 6 over 13. Now you have to make sure all three sides are proportional. So we're going to do this last one. If I take this and I divide this guy by 9, I get 6. Divide this by 9, I get, surprise, surprise, 13. So excellent work. These guys are similar because their sides are all proportional. Now, this is where those dashes are helpful for writing your similarity statement. I'm going to go 1 dash to the 2 dash. So that's SRT. So triangle SRT. And again, for your first one, it doesn't matter what order it is in, but the second one, the order absolutely matters. So because I did 1 dash, 2 dash, I have to do 1 dash, 2 dash here. So VWU. Oh, is similar to VWU. Excellent. All right, let's try another example. So make sure you've got your notebook and you're writing these down. Here's our next example. Are these similar by side, side, side? And if they are, I need you to write the similarity statement. So sometimes it's a little easier if you split your triangles up. So let's do that really quick. We have this guy right here is the smaller one, and that is T. I cannot draw triangles. I miss the corners, the vertex every time. What is wrong with me? I've been doing this forever. All right, so we've got these guys. See, I missed it that time. Jeez. All right, CD, B. Okay, so for the smaller one, we know that this is 56, and then we know this is 24. Now, because I know the whole big thing is 156 and this is 108, what I can do is subtract those two to give me 48. So now I know this side is 48. Okay, for the big side here, we have 182 up top and then 156 and 78. Okay, so again, I think it's helpful to do that, to like mark which corresponds with which. And again, I'm using those congruent symbols, but I'm not meaning it as congruent. So this is my small, this is my medium. Oh, I just did 3. This is my medium. This is my large. Okay, for this guy right here, we have small, medium, and large. Just did 3 dashes again. Man. Okay, so then let's see what we've got here. Let's compare them. I'll keep the green pen here. We've got 24 is our 1 dash, so that compares to 78. So 24 to 78 equals 48 to 156. 156. All right, and then 56 to 182. Now, in a previous in the previous example, I said you could do it a couple ways, and I showed you, let's go ahead and reduce those. These are kind of big numbers, so if you're allowed access to your calculator on a test, what you can do instead is just do 24 divided by 78. And so if we do that, we end up with 0.30 something. Actually, you know what we're going to do to make this a little bit easier? Instead, let's do 78 over 24. So now what I'm doing is flipping it, so I'm comparing the bigger triangle to the smaller one. And if I do that, 156 over 48, it doesn't matter as long as I'm consistent. And again, you'll see that I get that I've got 78, 156, 182, 78, 156, 182. And then I've got the smaller ones all on the bottom. You don't want to mix and match. So if I do that, that gives me if I did 24 divided by 78, I got a weird number. So let's do 78 divided by 24, and that gives me, a much nicer number. It is 3.25. So let's try this one. 156 divided by 48. Now, again, I get 325, 3 and 25 hundredths. Now, you have to make sure all three sides do this, otherwise it is not similar. So don't just do 2 and be like, yep, it's totally similar, we're fine. You got to check all three sides. And I do that, and I get 3 and 25 hundredths. So yeah, these guys are similar by side. Okay, so using my 1 dash, 2 dash, 3 dash, I'm going to write my similarity statement. And I'm going to say, okay, from my 1 dash to my 2 dash, that's SBT. And then is similar to triangle. And then I'm going to do my 1 dash to my 2 dash. So that's DBC. Excellent job. Now you know similarity by side, and are able to show that for a couple of different ways. If you have any questions, let your teacher know. We'll see you next time.